Welcome, happy learners, to a worked problems video.
Problem 286 is asking us to evaluate an indefinite integral. The variable of integration is theta. Note that we have a multiplicative sine theta against the differential d theta. The rest of the integrand involves cosine and powers. This is a statement of the problem. Let's begin the solution. First thing to do in your solution is to restate the problem. Looking at that sine theta, we know, as the rest of the integral involves cosine, that the derivative of cosine is negative sine theta. So that if we set a new variable u as cosine of theta, we get differential du as negative sine theta d theta. We can then isolate sine theta d theta and swap it out for du, but with a minus sign. Now that that's swapped out, we can look at the rest of the integrand, and wherever cosine appears, we swap it out with u. So we get binomial u minus 1, product with the binomial of u squared minus 2u, quantity cubed. Good. Now we do algebra. We're going to want to expand this binomial to the power 3. Power 3 in Pascal's triangle leads to binomial coefficients 1, 3, 3, and 1. So let's look at this binomial to the power 3, expand it out. The first term, u squared, we begin by cubing it. Add to that the binomial coefficient. Now take the first term and square it, and product with one copy of the second term. Add to that the binomial coefficient times one copy of the first term and two copies of the second term. And then finally finish with binomial coefficient 1 times the second term, now raised to the power 3. Simplify this expression inside the square brackets to get the next line. Now after that, let's distribute each of the two terms in the binomial onto this polynomial with 4 terms. Each of these 4 terms, if we multiply it by u, will increase the power on u by 1. So for example, u to the 6th multiplied by u becomes u to the 7th, resulting in these 4 terms. Next, if we distribute negative 1 onto these 4 terms, we simply have to take the 4 terms and change their signs. In this line, I have organized them such that corresponding powers match up to make it easy to produce the integrand in the next line. And since here we now have integrand, which corresponds with elementary integrals, we can easily evaluate. So for example, u to the 7th becomes u to the 8th. You increment the power and then divide by that power. And I'm going ahead all in one step and distributing the minus sign. As well, for example, if on 18, u to the 5th, power 5 becomes power 6, but then 6 into 18 provides us with 3. Very good. Going back, looking at the original statement of the problem, it's given in terms of theta. We want to make sure to return from the variable u to the original variable. And then that's done in our final answer, and we box it. Excellent.
Like and subscribe if you find this useful.